It's a molecular shape. We haven't said. I have not yet said what this geometry is. Okay. Well, this is the molecular shape, but we still have to give it a name for the geometry. Anybody know what the name of the geometry is? No? The geometry. What is the shape of the geometry? Trigonal pyramidal. Trigonal pyramidal.
How do you figure that out?
Well, it makes it kind of looks like this if you're drawing it. Kind of looks like a pyramid.
Okay, so that's cool. Yeah. Is it color?
Now we got to figure that out. That's a good question. All right. Now we're ready to figure out if it's polar or not. Question is, we got to have two conditions met for it to be polar. It's got to be an uneven distribution of bonds, and the bonds must be polar. Do we meet the first condition? Yes. Yes, the bonds are unevenly distributed. Okay. We got rid of this leg up here, and now there's this big old gap up here, you might say. All of these bonds are 109.5 degrees. But this up here, there's a lot more space than 109.5 degrees up there, so that's not an even distribution, is it? Okay, so we meet the first. No, we know that it's an uneven distribution. We haven't figured out the bonds are polar yet. Okay, to figure out the bonds are polar, we got to do a little simple math. Yes. Yep. All right. So we know it's an uneven distribution. What we want to find out now is if the bonds are polar. So we go back then to this periodic table with electronegativities. Okay? Periodic table with electronegativities. All right. So phosphorus has an electronegativity of 2.19. And yes. Bromine has an electronegativity of 2.96. Okay, so let's put that over here. We're at 2.96. That's the electronegativity of bromine. Okay? Okay, and then phosphorus is 2.19, so that's 2.19. That's the electronegativity of phosphorus, and we want to subtract. Okay? So when we subtract this from this, what do we get? What? 0.77. So now that's the electronegativity difference. Yes, for a Br to P bond. Okay? No, difference. Electronegativity difference. Okay? All right. So now you go back to your ranges here in your handout, and this is 0.77. So what kind of bond is it? Polar covalent. It's between 0.5 and 1.5. So now we know that not only is this an uneven distribution of bonds, we also know the bonds are polar. We've met both conditions, and we know this is a polar molecule.
You not put a polar covalent molecule?
You could. It has to be covalent for it to be polar, but you're right. A more complete answer is polar covalent molecule. Yes.
So if it was between 0.05 and 1.5.
Polar. The bonds are polar. Yeah. Yes.
I understand though, but like when it comes to this something called distribute, undistributed, how can you tell that it's even distributed?
Well, okay. I can give you a little bit of a crutch if it'll help you. How about that? Nothing wrong with crutches. I mean, if you break your leg, you're going to walk on crutches, right? Let me show you the shapes that are always going to be uneven. Okay? Bent molecules always are uneven. Okay? So we have a B molecule and an A molecule and a B molecule. That's a bent molecule. That's an uneven distribution. Okay? Trigonal pyramidal. those are always uneven distributions. So that's an A molecule here, a B molecule here, B molecule here. So this is coming out towards you, and that's going back behind. I should have made that a dotted line. Okay, so that's a trigonal pyramidal molecule. Okay, so that should be a dotted line. Everybody's got that? Yeah. Okay. Tetrahedrals are not, they're evenly distributed. I'm only listing the uneven distribution.
So if it got that line over it,
I don't quite understand the question you're asking.
like, if it had that, like the line above it, on the pyramid, yeah, like if it had
That'd be tetrahedral, and that wouldn't be uneven.
okay.
Okay, now, I want you to find page 21 of your handout. Page 21. Okay. This page actually answers your question. Okay? What it's showing you here is, if you read what's in these descriptions at the top of these columns, this is saying that it doesn't matter whether the bonds are polar or not. If you have these kind of arrangements, these are always going to be nonpolar molecules because they have an even distribution of bonds. Linear, trigonal planar, and tetrahedral. Okay? Alright. Here it's saying if the bonds are polar, then you have a polar molecule if the shape is bent or trigonal pyramidal. Okay? So, now, in this class, we don't really get into these more complex molecules in these last three rows down here.
Okay, so only focus on
The first three sets of illustrations are the ones that matter for this class. For your class, you don't get into those down there at the bottom at all. Okay? Those are honors chemistry molecules. Alright? And these are the ones that are most important. If you're going to be going into medicine, it's very, very unlikely you'll ever see these down here anyway. In medicine, you're almost always going to see just that setup at the top. Okay? Huh? Alright. Now, the only thing we haven't gotten into yet is the unusual case where we have both nonpolar and polar bonds in the same molecule. That's a different situation we haven't even talked about yet. I'm not ready to go there because I want to practice some more with the polar molecule stuff. Okay? Alright. Everybody okay with that? That's page 21 of your unit handout. Alright. Let me give you guys a couple of atoms to work with. Build a molecule and find out if it's polar or not. Okay? Alright, we need to remember it's got to be, if it's covalent, it's almost always going to be just the nonmetals over here. Okay? Let's build a molecule with nitrogen and chlorine. Build a molecule with nitrogen and chlorine. Determine if the molecule is going to be polar or not. Build a molecule with nitrogen and chlorine and determine if the molecule is going to be polar or not.